There's a very specific kind of anxiety that hits every developer eventually. And I mean, it's not the panic of a server crashing.
Right, because that's loud. It's obvious. Everyone knows exactly what to do when things are on fire.
Exactly. No, this is quieter. It happens when you open up a file, maybe something you wrote late on a Friday night like 6 months ago, or maybe something a colleague handed off to you right before they quit. You open it up, you look at the logic, and you see the shape.
The shape. You mean like the indentation pattern?
I mean the staircase,
Uh,
the arrow code. You know it starts innocently enough. You have one condition, like if the file exists, do this. Then inside that, if the permissions are writable, do this. Then inside that, if the file format is valid and suddenly your code is...
it's inching its way off the right side of the monitor.
Yes, you are 6 tabs deep and you have completely lost track of what happens if that very first if turned out to be false.
Yeah. Yes. The dreaded nested conditional. It really is the definition of spaghetti code.
Yeah.
And the problem isn't just that it looks ugly or that it breaks your line-length style guide. The real problem is cognitive load.
Cognitive load, right.
Yeah. To understand what is happening on line 50, you have to hold the state of line 10, line 12, and line 15 in your working memory simultaneously. And as much as we like to think otherwise, human brains are actually terrible at that.
We really are. I mean, I lose track after the second indentation. And that is exactly why I am so excited about the deep dive we are doing today, because we are unpacking a really elegant solution to this exact mess. We are going to look at a way to flatten that staircase and turn it into something readable.
It is a fascinating topic because it touches on both low-level syntax and high-level philosophy. We are dissecting a set of technical notes published literally today, February 28, 2026, from a site called qianmeng.org.
The author is Qian Meng. And right off the bat, I have to say I love how he positions himself. In an industry full of people calling themselves 10x engineers or ninjas or thought leaders, he refers to himself as an old software plumber and a night-long tinkerer.
Software plumber is such a precise, humble description. It implies that code isn't just about abstract architecture or beautiful algorithms. It's about pipes. It's about flow. Data comes in here, it needs to go there, and sometimes the pipes get clogged with bad logic. It is a very pragmatic way to view the job.
So today our mission is twofold. First, we are going to get our hands dirty with the plumbing. We are going to look at the specific Haskell technique he uses to clean up that nested validation nightmare we just talked about. And for anyone listening who thinks, oh, I don't write Haskell, please don't tune out. The logic here, the way of thinking about the problem, is applicable to almost any modern language.
Absolutely. The concepts of pattern matching and state management are universal.
And then for the second half of the dive, we are going to zoom out. Because this plumber, he isn't just plumbing code. When you look at his documentation habits from gardening to fish keeping, it reveals a mindset about tinkering that I think is actually the secret sauce to being a great engineer.
It is a masterclass in systems thinking, but let's not get ahead of ourselves. Let's start with the clog in the pipes.
Right. So set the scene for us. Where is our plumber working today?
He is deep inside a specific file. It's source/xs2ebook/cli.hhs. From the path, it's clear he's building a command line interface tool. And as anyone who has built a CLI knows, the most dangerous part of the application is the user input.
Because users will type absolutely anything.
And really will. They will type paths to files that don't exist. They will type nonsense. So he has to validate the arguments. Specifically, he mentions he just wrote a test case to ensure an input file actually exists before the program tries to eat it.
Okay, standard stuff. Does file exist, yes or no?
But here is where the trap opens up. He needs to update the validation logic to match that test. In a traditional imperative style, think Java C or even basic Python, you would naturally reach for the if statement.
Right. So you write if file exists, path.
Then you enter a block. Now, inside that block, you need to check if the file is the right format. So if valid format path,
Now we are 2 levels deep.
then maybe check if the user has read permissions. 3 levels. Now, here is the headache. What happens if the format is wrong? You need an else block for the second if. What happens if the file didn't exist in the first place? You need an else block for the first if, which is now 20 lines up the screen.
And your eyes are darting back and forth, up and down, trying to match the braces or the indentation to figure out which error message corresponds to which failure. It's miserable.
It creates a branching tree of possibilities that is very hard to simulate in your head. The author points out that he wanted to replace this nested if-then-else structure entirely. He wanted to turn that tree into a flat list.
And the solution he uses is something called pattern matching against a tuple. Now, I know we have some non-Haskellers listening, and tuple sounds like jargon. Let's break that down. what is a tuple in this context?
Think of a tuple simply as a fixed group of values, a pair, like coordinates on a map, x, y. In this case, instead of checking conditions one by one, he constructs a pair of results.
Okay, so instead of checking one, then entering a room and checking the other, he puts them side by side.
Exactly. Imagine a pair where the first slot represents the answer to does the file exist, and the second slot represents the answer to is the format valid.
So the ideal state, the happy path where everything works, would look like true.
Precisely. And this is where pattern matching comes in Haskell, and he references Elixir here as well, noting that this is bread and butter for Elixir devs. You don't have to write if x equals true. You can just tell the computer, does the state of the world look like this shape true, true?
It's almost like a shape sorter toy for toddlers.
That is a great analogy. You are defining the shape of success. If the inputs match the shape true, true, then run the program.
That sounds incredibly clean. It's just one line. If you
Yeah.
true, true, go.
It is. But the real magic isn't actually the success case. The real magic, and the reason this solves the spaghetti code problem, is how it handles the failures.
Because there are a lot of ways to fail. The file could exist but have the wrong format. That would be true, false.
Right. Or the file could not exist at all.
False and, well, false and something.
And that is the key. False and something. The author uses a specific feature of pattern matching called the wildcard. It's written as a simple underscore character.
The underscore. I love this little character. In code, it basically means I don't care, right?
It's the code explicitly saying whatever value is in this slot, it is irrelevant to me. I am ignoring it.
So in his validation logic, he has a line that matches false underscore.
Yes. False underscore.
Let's trace the logic there because this is the aha moment. The first value is false. That means the file does not exist.
Correct.
And the second value is the wildcard.
Which means I don't care if the format is valid or not. And logically, that is profound. If the file isn't there, you cannot check its format. The second question is moot. It doesn't matter.
In a nested if statement, you have to mentally work that out. You look at the else and think, okay, we skipped the inner loop, so that means, but here the code shouts it at you. False underscore means if it's missing, nothing else matters.
It clarifies the intent of the programmer. It converts the logic from first do this, then check that into a truth table. You can look at the code and see a table of every possible state the program can be in right there in one column. First, true means go. Second, false underscore means error file missing. Third, true false means error, wrong format.
It's declarative. You're describing the scenarios rather than the steps to get there. It feels so much more readable.
It removes the how and focuses on the what. It reduces that cognitive load we talked about.
Yeah.
You don't have to remember the previous lines. You just look at the pattern in front of you.
Sure.
It is a single readable block.
Is this unique to Haskell? I feel like I've seen similar things in Rust or modern Java recently.
It is spreading, thankfully. Rust has amazing pattern matching. Java's is introducing it slowly. But functional languages like Haskell and Elixir were the pioneers here. The author specifically notes that if you come from Elixir, this feels like bread and butter. It's just how you think. But for someone coming from an older imperative background, seeing that false underscore wildcard is a revelation.
Now, while he is refactoring this, turning his spaghetti into this nice, neat tuple, he mentions he fell down a bit of a rabbit hole, which frankly is the most relatable part of the post.
The classic tinkerer distraction. You fix one thing and you spot something else and go, wait, how does that actually work?
He started looking at the pure function. Now, we are getting a little deep into the weeds here, but stay with us because it explains how smart these modern compilers are. Pure in Haskell isn't about moral purity, is it?
No, not quite. Pure is a function used to wrap a value into a context. Think of it like putting a letter into an envelope. If you have the number 5 and you want it to be inside a list or inside an error handler or inside an I/O action, you use pure.
But here is the question the author asked. If pure is generic, if it can create any kind of envelope, how does it know which one to use? He didn't tell it, make this a list, he just said pure.
It is a great question. In many languages, you have to be explicit. You'd say list.of5. You tell it the constructor. In Haskell, you just say pure 5.
So how does the compiler know? Is it guessing?
It's not guessing, it's investigating. This brings us to type inference. The author realized or reminded himself that the answer lies in the signature of the function.
The signature, that's the line at the very top of the file, right? Validate args : :
Exactly. He lists it. Validate args : : args arrow IO parse result args.
Okay, that looks scary to the uninitiated. Break it down for us.
It's just a contract. It says this function takes some arguments, args, and it promises to return an IO action.
IO stands for input-output.
Right. So the compiler looks at that signature. It sees the promise you must return an IO. Then it looks inside the code and sees pure, connects the dots. Since you promised an IO at the top, this pure at the bottom must mean wrap it in an IO.
It's working backwards.
It is. It's Sherlock Holmes. It looks at the crime scene, the result, and deduces what the tool must have been.
He also mentions the do block playing a role here.
Yes. In Haskell, do notation is used to chain these actions together. The author notes that the context of the do block gives the compiler even more clues. It's like a puzzle where the border pieces are already put together so the compiler can easily figure out the middle pieces.
You know, people often say Haskell is magical, and they usually mean that as a criticism, like, I don't know what's happening under the hood. But this explanation makes it feel rigorous.
That is the irony. It feels like magic because you write less code. You don't have to type io.wrap value. But it works because the types are so rigid. You define the shape of the universe, and the compiler ensures everything fits. If it didn't fit, the code wouldn't compile.
Let's recap the technical side. The author validates his arguments using tuples to avoid nested ifs. He uses the wildcard to ignore irrelevant failures. He marvels at the type inference engine, and then he publishes the note, Part 70. And this is where I want to pivot, because if you just read that one technical tip, you get a nice coding takeaway. But if you click on the home button of qianmeng.org, you get a life lesson.
You really do. The sidebar of this blog is a rabbit hole in itself.
It is incredible. I was scrolling through it before we started recording. Obviously, you have the text stuff. Notes on Haskell, Python, Rust, Go Cutter. The guy is a polyglot. He is learning everything.
But keep scrolling.
Notes on gardening, notes on fish keeping, notes on photography, notes on dieting, notes on home improvement.
And notes on networking. He's got a post about benchmarking Wi-Fi 7.
But it's the specificity that blew my mind. I expected gardening to be generic photos of flowers, maybe a sunset. But I'm looking at the title here. Notes on Gardening, Part 821. Part 821, Why Your Mint is Not Growing.
And Part 819 on phosphorus deficiency.
He isn't writing poetry about nature. He is debugging his garden.
This is the plumber mindset we talked about at the beginning. Think about it. What is a software bug? It's a system behaving in an unexpected way because of a hidden variable or a resource constraint.
And what is a yellowing mint leaf?
It's a system behaving unexpectedly due to a resource constraint, lack of phosphorus. He is applying the exact same diagnostic loop to his plants that he applies to his Haskell code.
Observe hypothesis, test, fix, document.
Especially the document part. That is what separates a tinkerer from a scientist. The documentation.
Let's talk about the fish keeping. Part 201, balancing algae growth. Part 202, will guppies eat? I assume he means fry.
Likely. An aquarium is a closed-loop system. It has inputs, food light, and outputs waste algae. If you let the processes run wild, the system crashes. The fish die.
Sounds a lot like a memory leak in a server.
It is exactly the same principle. Resource contention, runaway processes.
Yeah.
I would bet money that dealing with the algae in his tank makes him a better debugger for server memory leaks. He understands equilibrium. He understands that changing one variable affects the whole system.
And he's doing all of this in public. The sheer volume, we're looking at the archives for February 2026. How many posts did you say?
The counter says 84 posts.
In 1 month.
In 1 month. That is nearly 3 posts a day.
That is intimidating.
It is, but look at the format. They are notes. They aren't polished SEO-optimized commercial articles trying to sell you a course. They are logs. He is logging his life's work.
It's the open source philosophy applied to existence. He mentions in his About section that he supports FLAFAS, free libre open source software.
He lists the Electronic Frontier Foundation,
Yeah.
the Tor project, Wikipedia. He is clearly someone who believes that information wants to be free.
But think about the discipline required to write 84 times a month. Most of us solve a problem like, oh, I fixed the Wi-Fi by changing the channel, and then we just move on. We forget it 5 minutes later.
And then 6 months later, the Wi-Fi breaks again, and we have to relearn it from scratch.
Exactly. We pay the learning tax twice.
Qianmeng doesn't pay that tax. He wrote Part 70. He wrote Part 201. He is building an external brain. If he ever encounters that phosphorus deficiency again, he doesn't have to research it. He just checks his own documentation.
It challenges the advice we usually hear. You know, if you want a successful blog, niche down, don't confuse the audience. If you code, don't talk about fish.
That is great advice for a brand. It is terrible advice for a human being. A tinkerer connects dots between unrelated fields. If he had separated his gardening blog from his code blog, he might lose that cross-pollination of ideas. The plumber identity holds it all together. He plumbs the data, he plumbs the water, he plumbs the nutrients. It's all the same job.
It makes me wonder about our listeners. We all have those nested ifs in our lives, right? Places where we are overcomplicating things.
Absolutely. We over-engineer our morning routines or our diet plans or our organization systems.
But we also all have those small wins. The mint leaf turns green again. The validation logic passes the test.
The challenge is, do you value those wins enough to write them down?
That's the heavy question.
It is. Because when you write it down, you validate it. You turn a fleeting moment of aha into a permanent asset. You become a scientist of your own life.
So to bring it full circle, we started with a piece of code, source/xs2 ebook/cli.hs. We saw how a tuple true can save you from a headache.
And how false underscore allows you to gracefully ignore the noise.
And we ended up in a garden checking phosphorus levels.
The principles are universal. Simplify the logic, explicitly state what matters and what doesn't, and document the fix.
I think that's the takeaway for me today. Think like a plumber. Whether it's data flowing through a Haskell pipe or water flowing through a fish tank filter, keep it clean, keep it simple, and if it leaks, write down how you fixed it.
Couldn't have said it better myself.
So here is a question for you to chew on as you go about your day. Where is the spaghetti code in your daily routine? Where do you have a mental process that goes if this, then this, but wait, if that? Can you replace that mess with a simple pattern match? Can you just look at the whole state of things and say, does this match my criteria?
Sometimes you just need to wildcard the rest and move on. False underscore and walk away.
I love that. Wildcard and walk away. That's going on a t-shirt.
I'd wear it.
Thanks for diving deep with us today. This was a fun one.
Always a pleasure.
We will catch you next time on the Deep Dive. Stay curious.